In this video, you're going to learn about what a discriminant is. You're going to learn how it determines the nature of a quadratic graph. You're also going to learn about how coefficients of x squared, determine if the graph is upward or downward opening. We're also going to go through one practice problem, and then we'll call it a day and end the video. That being said, let's begin. Today, we're going to be learning about the discriminant. Now, the discriminant, you might be familiar with the quadratic equation. It's this little guy up here, x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. And the discriminant is actually this little guy here. The stuff in purple is the discriminant. That's what the discriminant is. The stuff highlighted in purple. Not highlighted, but surrounded in purple. And this is actually very important. For the purposes of this video, I'm going to use D in this color as the discriminant. So what happens when b squared minus 4ac, or the discriminant, is greater than 0? Well, this discriminant thing here actually determines if the graph has x-intercepts or not, if the graph has solutions or roots. So it just determines if your graph has solutions, which is why it's very important. So if your discriminant is greater than 0, then your graph will have two real and distinct roots. So they're going to look something, your graph is going to look something like this. Something like this. So these graphs up here, they intersect the x-axis at two different points. A circle, I want a rectangle. There you go. So these graphs here, they intersect the x-axis at two different points. Maybe you can say that this is x equals to 5, and then you can say that, I don't know, x equals 0.5. So these guys, two real and and distinct roots. Because they're different, they're not the same. So what happens if your discriminant is equal to 0? Well then, your graph is gonna be tangent to the x-axis. What does that mean? Tangent, that sounds pretty scary, right? I know. Tangent just means touching the x-axis once. Touching the x-axis once, so it's just gonna touch like that. Or, if the coefficient of x squared is negative, it's gonna just touch like this. So it's gonna have real and repeated roots. Real and repeated roots. This just touches the x-axis at one point. Maybe this is, I don't know, x equals 2, right? So it just touches. That's what a tangent means, just touches. You might have heard in physics class that, in order to calculate instantaneous acceleration, you need to take a tangent line. Basically, a line that intersects the curve once, which is here. So if the discriminant is equal to 0, then your curve is just going to touch the x-axis at one point. What happens if your discriminant is less than 0? Then your curve will have no real solutions or roots. And what will that look like? Well, this means solutions just means x-intercept, essentially. That's what it means. So if there's no real solutions, and real solutions just mean x-intercept, then this means your graph is going to be entirely above the x-axis, or entirely below the x-axis. Roots just means, like, intersections with the x-axis, right? Well, it doesn't have any of those, so it has no real solutions. It doesn't have any real solutions. So if your discriminant is less than 0, your graph is either going to be entirely above or entirely below, depending on the coefficient of x squared. So why do I keep on saying coefficient of x squared? So let's just say we have a simple curve or parabola of y is equal to x squared and y is equal to negative x squared. Now I want you to take a moment and try and graph these two on some paper or a graphing software. All right, so if you graph, let's label this number 1, let's label this number 2. So for the first one, your graph is going to look something like this. So this is your y-axis, this is your x-axis. Your graph is going to look like this, right? It's going to be opening upwards. It's kind of like how I like to remember it. It's if the coefficient of x squared is positive, your graph is going to be happy, right? But what happens if it's negative x squared? You see this negative here? This is actually negative 1 and then x squared, but we don't really write negative 1, so it's just negative x squared, right? So if the coefficient of x squared is negative, then your graph is going to look something, like, this. So this is going to be your point 0, 0, right? And then this is your y-axis, this is your x-axis, and this is also 0, 0, right? So you can see that this graph is opening downwards. So open downward, for number 1, the graph will be opening upwards. I hope you can see where I get that from. And for number 2, the graph is going to be opening downwards. So like a sad curve because it's negative. So now that we understand discriminants, let's do some questions. So the first question is, for what k values is the graph of y is equal to 2x squared plus 2x plus k to be number 1, always positive, and number 2, have real and repeated roots, and the third one is have real and distinct roots. Maybe it's not to be. Maybe let's do this. Don't want a grammatical error to be. All right. So the first one. What does be always positive mean? Well, this means our curve. Let's highlight this curve in green, a nice little green color. So this means our curve is going to have to lie entirely above the x-axis. Why? Because these y values here are positive and the y values here are negative. So if you want your graph to be always positive, remember that this is y equals, right? So based on y, right? So in order for your graph to be always positive, it's got to lie completely above the x-axis. Why? Because when you're at the x-axis, when you're on a point on the x-axis, y equals 0. So that's why you might see some coordinates on a plane to be like 0, 0, because at the x-axis, y is 0. So your graph needs to be greater than 0, right? So what we can do is we can use the discriminant. If you remember, if your discriminant is less than 0, yes, if your discriminant is less than 0, your graph will not be touching the x-axis. It won't have any real solutions. It's going to look something like this or something like this, depending on the coefficient of x squared. This is going to be negative a, this is going to be positive a, and this is going to be negative a. Because remember, x squared is in the form ax squared plus bx plus c. This is your quadratic standard form, I think. Yeah. So, negative plus positive a, negative a. If we look at the coefficient of x squared in this equation, what is it? It's 2. 2 is greater than 0, therefore 2 is positive. So the coefficient of x squared is positive. Therefore, our graph is going to look something like this guy here. So if we would want it to be always positive, our discriminant needs to be less than 0, right? That makes sense. So we need to set our discriminant equal to 0. So what does our discriminant equal? Well, our discriminant equals b squared minus 4ac, yes? So let's compare it to this equation, 2x squared plus 2x plus k. So what do you think is our b? If I were to say that this is ax squared plus bx plus c, what do you think is b? Well, b would just be 2, c would be k, and a would be 2. So let's plug these values in. So our discriminant is going to be equal to 2 squared minus 4 times 2, minus 4a, right? Minus 4a, times minus 4 times 2, times k, times k. But why is it k? Why isn't it a number? Well, k is a constant, and k is a number. It's constant. It's your constant term. C represents your constant term, all right? So your discriminant is going to be equal to 4 minus 8k. But remember, we want this graph to be always positive. So always positive, set d to be less than 0. This is so that your graph lies completely above the axis, completely above the x-axis. So what we want to do is we sub this value in here. So d is equal to 4 minus 8k. Therefore, 4 minus 8k is less than 0. Therefore, negative 8k is less than negative 4, and therefore k is greater than 1/2. So for what value of k does the graph of y is equal to 2x squared plus 2x plus k to be always positive? Well, I would say that k has to be greater than 1/2. I would say that k has to be greater than 1/2. What about for what k values sorry for the bad English, is the graph of this to have real and repeated roots? What does real and repeated roots mean? What does that mean again? I've forgotten. Well, if you remember what real and repeated roots are, that just means the graph is tangent to the x-axis, meaning that the graph just touches the x-axis. It doesn't go beyond, it just touches like this. And what is the condition for real and repeated roots? The discriminant has to be equal to 0. We already evaluated our discriminant right here in the previous question or previous part, and our discriminant is equal to 4 minus 8k. Therefore, we can say that 4 minus 8k, should label this 2. Therefore, we can say that 4 minus 8k is equal to 0, right? Because our discriminant needs to be equal to 0 in order for our graph to just touch the x-axis, to have real and repeated solutions, to have real and repeated roots, right? So 4 minus 8k is equal to 0. Therefore, negative 8k is equal to negative 4. Therefore, k is going to be equal to what? 1/2, because you divide both sides by negative 8. So for what k values does our discriminant, for our graph to have real and repeated roots, k is going to have to be equal to 1/2. For what k values is the graph of this to have real and distinct roots? Well, we need to do the same thing for a discriminant, right? So for number 3, what does having real and repeated roots mean? Having real and repeated roots means that your graph cuts the x-axis. It's not tangent anymore. There's two there's two distinct points here. There's two different points. This could be like, I don't know, x equals -1. This could be x equals 3, for all I know. Did I write that question right? Yeah. To have real and distinct roots. Yes. So we want this graph to cross the x-axis. So therefore, do you know what the condition for this is to be on any curve? Well, our discriminant is going to have to be greater than 0. What's our discriminant? For this particular equation, our discriminant is 4 minus 8k. Our discriminant for this particular equation is 4 minus 8k. Therefore, 4 minus 8k is greater than 0. Therefore, minus 8k is greater than -4, and therefore k is greater than 1/2. So, for what k values that are needed, what is the k value that we need for our graph to have real and distinct roots? Well, I would say that k is going to have to be less than 1/2, right? So, I hope, oh sorry, k has to be greater than 1/2. Wait, that doesn't make sense. K has to be, did I flip it? Ah, sorry, okay, there we go, we made a mistake. We forgot to flip the inequality. So k has to be less than 1/2. So we go back here. Yeah, alright, good. So k has to be less than 1/2. Alright, I hope you learned something about discriminants. I did go a little fast in this video. I just want to try a new teaching style. Maybe you guys like fast stuff. Alright, so hope you've learned about discriminants. Hope you found it useful. Looking forward to see you in the next math, physics, chemistry video. Alright, have a good one.